Alright, so let's focus on the non-inverting amplifier. What we're going to try to do is explain how to get gain for this specific non-inverting amplifier. And notice that the voltage input is connected to the non-inverting side. And then the inverting input is grounded. The resistors are still there as for the inverting configuration, and the assumptions that we've had before are still valid, and those two assumptions are that the inverting voltage is equal to the non-inverting voltage. So there's a virtual short circuit between the the inverting voltage, or the voltage at the inverting input, and the voltage at the non-inverting input. So whatever voltage is here automatically is here. That's why this is VI, okay? Because VI is here. The other assumption is that the two currents into the inputs of the inverting side and the non-inverting side are both equal to 0. This is true for an ideal amplifier, any ideal amplifier. So the input into the inverting side is 0. The input into the non-inverting side is 0. And our goal is to find gain, which is always defined as the output voltage to the input voltage. Alright, and here's how we're going to do that. Right? We know, because that there is a voltage here, that the current will flow here, and then it will flow here. We'll call it I2. It's going to flow through this resistor, I2. It's going to flow down here. And then when this current flows here, we know this current is 0, it has to flow this way. So the current is going to continue to flow this way, but we'll call it I1 now. And it's going to flow through this resistor to ground. I1. Okay, so once again, the current goes up here. This is still I2. Goes here through this resistor down here. Because current here is 0, it goes through this resistor and it grounds, right? And so watch this, right? Remember that the current here, I2, is equal to the voltage difference across this resistor. So the voltage here at this point, which is VO, minus the voltage here, which is VI, divided by the resistance, which is R2. Okay. Now check this out. The voltage drop across this resistor is the voltage here, which is VI, minus the voltage here, which is 0. So minus the voltage here, which is 0, over the resistance, which is R1, and that equals to I1, right? Now, what do we know about I2 and I1? We know that they're the same current. So we know that I1 is equal to I2. And so these two things are equal. So VO minus VI over R2 is equal to this. VI minus 0 is VI over R1. Okay. Now here we can use algebra to multiply R2 on both sides. And now we get a pretty nice equation here that says VO minus VI is equal to R2 over R1 times VI. One more step, add VI on both sides. That cancels that. And we have VO is equal to R2 over R1 VI plus VI. Last step, let's factor out the VI. And so we have VO is equal to VI times R2 over R1 plus 1. Right, so we just factored out the VI. And last step is divide by VI on both sides. And now we have VO over VI is equal to R2 over R1 plus 1. And this right here is the gain. And so, quick example here, if you have an input, in other words, a input of 1 volt with an R2 being 10K, R1 being 1K, then what is the output? Well, we know that the output given by this equation is the Vn, which is 1 volt, times R2 over R1, which is 10K over 1K plus 1. So it's going to be 1 volt times 10K over 1K is 10 plus 1. And so then that's 1 volt times 11, which is going to be 11 volts. So when you input 1 volt, you get 11 volts out.